Thank you, everyone, for attending today's webinar, Don't Settle for Dirty Panels, O&M Can Save the Day, sponsored by EDF Renewables and hosted by Solar Power World magazine. We would like to thank Jeff Gilbert, Director of O&M Services at Vigilant Energy Management, and Angelo Purpura, Manager of Technical Services for Swinnerton Renewable Energy, for sharing their expertise on operations and maintenance with us today. Jeff serves as the Director of Operations and Maintenance for Vigilant Energy Management, overseeing 30 megawatts of PV assets for a variety of clients, including utility companies, government agencies, and solar contractors. Also, as President of Azimuth Solar Training, Jeff provides technical and business development training for the solar energy community using his 19 years of experience in the renewable energy industry. Angelo manages the Swinnerton Renewable Energy Technical Services Division, which is comprised of the Solar Operations and Maintenance Field Technicians and the SOLVE team, Swinnerton's proprietary solar system monitoring platform. Angelo is responsible for the field operations of more than 600 megawatts DC of utility-scale solar PV plants and stays ahead of industry trends. I'm Frank Andorka, Editorial Director of Solar Power World, and I'll be your moderator today. Just a couple of housekeeping details before we get started. If you wish to tweet about this webinar anytime during or after, you can use the hashtag SolarWebinar. We love social media, and we hope you do too. You can follow us at Solar Power World or me at SolarFrankA. We will have a Q&A session after the presentations. Submit your questions, and we will ask them after all the presenters are finished. Questions can be asked using the GoToWebinar on your screen. Presenters will be available to answer questions after the presentation. And without further ado, I will hand the mic over to Jeff Gilbert, Director of O&M Services at Vigilant Energy Management. Jeff?
Thank you very much, Frank. Oops, went too far. All right, so welcome everybody. It's a pleasure to be here to talk about O&M services with you all. So PV operations and maintenance, the investment that could save your investment. I am assuming that many of the listeners today are asset managers of some type, whether you're actually technically inclined to go out and work on these systems, or you may be an asset manager and investor. So these are all good tips for you, and I'll share my learning experience with you. A few words about Vigilant Energy Management. We, as mentioned, operate and manage 30 megawatts, over 30 megawatts, and we're probably going to double in 2014. We're in negotiation with some large contracts. We're led by an NABCEP certified engineer, and our technicians are NABCEP certified and or electricians. We have several master electricians as well. And we use state-of-the-art test equipment and recording capabilities. This really, I can't overemphasize this in the world of operations and maintenance, to have the right tools for the job. So what is the purpose of operations and maintenance? The first thing is, and the one that most people would think about, is maximizing your return on investment. This, of course, is very important for owners and investors, because they want to make sure they get their maximum return. This makes complete sense. The second purpose is to maximize the total PV production. And you might be thinking, well, so what's the difference? It's still return on investment, isn't it? Well, it's coming at it from a different point of view. So the first one is entirely monetary. And the second purpose is everything that's not directly about money. So let's say that your company is trying to brand itself as being green, as being, for the environment, and maybe you're trying to offset 100% or some portion of your consumption with renewables. So by maximizing this total production, you've now met some quota for your claim of maximizing or minimizing your impact on the environment. This is part of branding, part of marketing. All right, so why is O&M so important? We talked about the purpose, but let's talk about some of the nitty-gritty of operations and maintenance. So the reason is that it's so important is because stuff happens. And when stuff happens, that means that the power output of a PV asset or system goes down, and that's bad. So this is all about how to keep that operating at maximum. So what are some of the things that can happen? You can get inverter filters that get dirty. Now, you should absolutely expect this to happen. Every larger inverter is going to have cooling fans, and they will have filters, and these filters will get dirty. And if you don't have some kind of a regular maintenance program, then the system's going to fail. So you got to be there for it. Also, because debris and weeds can cause acute shading. You can see there on the left, there's a kite that got itself wedged between the modules. And to the right, there's some other piece of plastic debris that just the wind blew into the array. The other two pictures are showing tall weeds that have grown up between the modules. Now, normally, an O&M contract would include grass cutting if it was a ground-mounted system. So this shouldn't happen. But I've driven by quite a number of sites where I've seen the grass very tall, and things like this happen. And when you have these close shadows, these acute shadows, you're not only losing production, but you're also potentially damaging the cells. You will have hot spots, and prolonged shading like this can cause actual damage to the cell. All right, next picture here, we have combiner boxes getting wet inside. Now, this is actually quite common. And you might think, well, wait a minute, most combiner boxes, if you're familiar with the equipment, you know that most combiner boxes, if not all of them, are NEMA 4 rated, which means they are watertight. They're not supposed to get wet inside. The problem is when you have conduit connections and moist air migrates into the boxes, and then, let's say the components in the box are cold, you get constant condensation that builds up, and then you're going to get corroded parts. We've seen quite a number of ground faults happening because of this. So these, you got to think about these. And this is really a workmanship issue. We found with quite a number of sites that we've taken over management of that everything looked fine during commissioning, but after a year or two, then you start to really see these problems. We also have electrical components that fail. You just got to expect these, especially with these larger, 300 kilowatt to 1 megawatt size inverters. It's Murphy's Law. Stuff is just going to happen. The picture here to the left is showing burned out resistors on a circuit board. The picture in the middle is showing a fuse holder in a combiner box that came from the factory, not fully tightened. The set screw that's supposed to make electrical contact with the bus bar is not fully tightened. And so we had a hot spot there. You can see the plastic was actually melting. When we removed this, all three of those fuse holders were melted together into one big block. So I'll talk more about how you detect these sort of things because this was not visible. When I opened up the box, I could smell something. That was one indicator, but we also looked at it with the thermographic camera, and I'll show you some pictures of those images later. The third failure here is of a burned out power processing unit. And from a distance, this isn't visible either. So, but these are the kinds of things that can happen. When you have a salesperson that sells a project, they want to make the sale. They're gonna say things like, these systems are, designed to last for 30 years. They have no moving parts, and so it's a no-brainer to invest in solar. And that is true, kind of. As long as there is a good maintenance program, you can get these systems back up and running quickly. You got to have a very quick response time. I can't overemphasize that. But to say that these systems are going to be maintenance-free for 30 years is that's just not true. Another thing that can happen is panel breakage. I got lots of pictures here of panels broken. This first one was caused by a dropping clam. And I'll talk more about that in a second because I got some more pictures there. The one in the middle was a flying projectile, most likely a rock. And the third one was because of many clams being dropped. You're thinking, well, why would there be clams on solar panels? As it turns out, this one project was installed near the coast, and it turns out that trash trucks parked down below, and the seagulls decided to make this their nest. One of the things that seagulls do is they go get clams and they drop them on hard surfaces from about 50 feet up. And, you know, when the hard surface is solar modules, you get a whole lot of breakage. But, you know, who would have thought, right? When you're investing in a system, there weren't any seagulls at the site when this site system was first being scoped out, and yet there they were, dropping their clams. So you just have to have a maintenance program that is going to cover these sorts of things. Obviously, the maintenance program, you know, annual fee, if it's set up with some kind of a program, is not going to cover the, like an insurance policy. It's going to be more of a time and material sort of fix because it's completely unpredictable. But having a program in place so that somebody can just act quickly and handle it is where the program is most valuable. Here's some examples of just quality assurance and quality control not being done either during installation of the project or during the manufacturing of the components themselves. The picture here to the left is of a combiner box that had a loose set screw. And you can see on the picture below, you just can't see that. It looks like a fine picture. You might open it up and say, yep, everything's fine, good, let's move on. But until you pull out your infrared camera and look at it and see that hot spot, that hot wire, you would not know that there's a loose connection. And that's either going to cause a fire or some kind of a meltdown or just cause losses continuously over time. The three pictures to the right show modules with defects. You can see all those bright spots on those modules. Those are cells that are overheating because of some type of defect in the modules. And we're still working with the manufacturer there to determine exactly what's wrong. The picture just to the right, upper right, is what it looks like when a diode goes out. 1/3 of that module was out of commission. You can see it's actually becoming a consumer of electricity rather than a producer. That's why it's a hot spot there. And then the picture below is a junction box that's overheating because of loose wire connections inside. Again, without a thermographic camera, you would never know these things. So it's imperative that the O&M team have the right tools for the job. All right, so I'm going to go through a little bit of a cost analysis here of what can happen in a megawatt-sized system if it's down for a whole week. So let's say this hypothetical system, 1 megawatt in size, goes down, and let's say it's going to be in Maryland. That's where Vigilant Energy Management is based, so I chose this area. And let's use this hypothetical example of an inverter blowing out some resistors. So the system goes down, and the objective, of course, is to get it online as quickly as possible. But for every week that this system is offline, it is costing the owner a lot of money. Now, let's look at the numbers here. So 1 week average production from a system like this, and this is just taken from PV watts, is 25,900 kilowatt hours in that 1 week. Now, if we look at the cost of electricity for this area, just as a given, it's about 10 cents per kilowatt hour. So what do those two add up to? It's about, and also the value of solar renewable energy credits in Maryland. We have an SREC program due to renewable portfolio standards. And in Maryland, as of November, the market price for an SREC, which is a megawatt hour, was $138. All right, so let's crunch some numbers here. The cost of lost production is simply the kilowatt hours times 10 cents a kilowatt hour. That's $2,590 for that 1 week. Then we have the lost SRECs. Same production times $138 per megawatt hour. That comes out to $3,574. You combine those together, and that's over $6,000 per week lost. And you're just never going to get that back up again. So response time is very critical. And this isn't during just regular business hours. Your O&M team needs to have a plan for weekends and holidays. You know, who's going to be on call? If you have an in-house maintenance crew, are they going to be ready on weekends and holidays as well, so you can get that going again? One little note here at the bottom that in this analysis, we weren't even taking into account the offset demand charges. You know, most commercial entities will have not only kilowatt hours that they're charged for, but also kilowatt for peak time of day. So that was not taken into account in this analysis. So you might be wondering, should I do O&M in-house? You know, if you're an EPC and you develop these projects yourself and install them, you may manage your own portfolio to some size. Or if you're, you know, if you do, you know, hundreds and hundreds of residential systems, it's much more common that you would be the O&M provider for those residential systems. But once you get to the big, you know, tens of megawatts, that's when you're going to have to ask yourself, should I do it in-house or should I outsource? And, you know, of course, the intent with keeping it in-house is to save money by utilizing your existing maintenance personnel. It just makes sense. But a word of caution, troubleshooting modules, inverters, and monitoring takes years of experience. You know, if you're working with small string inverters in a residential system or even microinverters, those are easy to work on, especially microinverters. If they go bad, you just swap them out under warranty, always easy. But once you get up to the bigger systems, it takes a dedicated crew, full-time, with a lot of experience to get these inverters up and running quickly. Also, O&M requires extensive and sophisticated analysis equipment and also the experience necessary to properly make use of the data. You know, it's one thing to say, all right, well, yeah, we got a monitoring program here, and we have them set up for alerts. So, you know, anytime the system goes offline, we'll just go and address the problem. But what if the system is performing badly, but hasn't quite hit the threshold of an alert? If you don't have an analyst there full-time looking at these numbers and always crunching, you know, looking for opportunities to increase the productivity, you're going to miss a lot of kilowatt hours. And also, just to do analysis and present a good report to your client, being able to understand all the metrics and numbers is critical. Also, when a company specializes in O&M, they're really going to get good at it. And you can think of the analogy to medicine. You know, if you have something wrong with you, let's say you need, I don't know, cataract surgery, and you just go to a general surgeon, you know, you're going to get a certain level of expertise. But hopefully that general surgeon is going to refer you to an ophthalmologist who understands cataract surgery, a specialist. Same thing with working on inverters and sophisticated monitoring equipment. If you're looking to somebody who is a general maintenance person, really good with HVAC equipment, understands general maintenance of a manufacturing facility, really bright people, jack of all trades, they're going to be good for the simple stuff. But once you get into diagnosing and analytics, you really want a specialist. All right, that's it. So I'm going to take questions at the end, but I'm going to give the floor to Angelo.
Thanks, Jeff. We really appreciate that great presentation. Now I'll turn the mic over to Angelo Purpura, Manager of Technical Services for Swinnerton Renewable Energy. Angelo?
Yeah, thank you, Frank. I'm trying to work the slide here. There we go. Okay, thanks. When we were asked to discuss this topic on how O&M is done and what does it take to do it right, it made us really think about our internal process and how we developed it, how to break it down into manageable parts that we could share. Back in 2008, we initially got into the O&M business for the protection of our own plants. We're also an EPC contractor as well. So as you know, you have performance guarantees, availability, warranty resolutions, and things that come about as part of being an EPC and then taking over your O&M. We realized very quickly that we needed a higher level of sophistication. I think, you know, a lot of people have this misconception that you wash modules and you cut grass, which is truly a function or one task, but the detailed aspects of operating a plant are much deeper. We chose to break this process down into 3 distinct categories, or as we would call it, an equation, which is about people, action, and data equals smart O&M, or the technical trifecta. Jeff touched on, you know, on the lower right corner or lower left corner with data with analytics. We chose, because that area that Jeff mentioned, the analytics portion is so important, or was so important to us, we chose to bring that in-house and develop our own monitoring system as a result of what we were seeing in the industry. This is by far not an end all for all O&M. This is just something that works for us, and we've been successful at it. Like Frank mentioned, we do have 600 megawatts that we're currently operating. The great thing about our model is we wanted this model to be fluid and be something that can adapt with industry changes. So we change it as new technology arises and new issues come about. We're always learning. Let's go here. Oops. Okay. So we pride ourselves in a full cycle approach and using a feedback model that actually works. Going from the concept all the way to commissioning and operations, in PV lifecycle, we use a model called LCOE, levelized cost of energy. The term levelized is defined as a sum, an equal sum divided into equal amounts over a period of time. So when you add that with time value money, you have this equation. The one link that we insist upon, whether we are the EPC on a project or not, is we want to be involved in the commissioning process of the project as we transition from commissioning into operations. This is the juncture for us where we feel we get the most benefit from the plant. We get a greater understanding as the commissioning process is being performed. And we also develop the maintenance plan based on what we're seeing at the plant on that day. The top right photo shows an image of a plant that we all love to inherit. It's clean, it's beautiful. The bottom right is the reality of what we truly get stuck with. This happened as we were commissioning, and we were looking at doing some IV curve tracing on this site. Without being involved in the commissioning portion of this and realizing that soiling was such an issue on this particular site, we would have found this out much later in the game, and typically it'll be at the point where you receive a bill for liquidated damages from your owner because you may or may not have met your performance guarantees. So we were able to adjust our maintenance program to account for this specific issue on this site. So when we take the equation of levelized cost of energy, our approach is, why can't we do the same thing with O&M? Some of this may be a little bit of what Jeff had mentioned. In our opinion, these are the three important items that matter to us. We really need smart people. The bullets describe the types of technicians we look for. At a minimum, we realize that all of these have to be true. If they're not, O&M pricing goes up, which ultimately affects your owner's pro forma and their return on their investment, which is something that nobody wants to do. Our field technicians, they need to have an understanding of the specific plant design and an understanding of the PV behavior given that certain region. Not all plants react the same. There is no one-size-fits-all model for O&M. We feel that each plant has to be independent of each other. They need to understand how to optimize the crews. You know, we put a bunch of guys on something that costs pennies a watt to install. That's really not the answer, and that's not in the direction that we want to go with. It's a very inefficient approach. Our centralized support requires us to have a strong performance team. They have to be capable of helping the people in the field. There's a lot of the field technicians, as you know, are remote. They're in the snow, they're in rain, or there's something happening. The field staff the office personnel is a much more controlled environment where we can monitor things from the ops center, help our technicians derive a solution and keep them moving forward. Our continuous training program, safety is paramount and has to be continued with whatever we do, given different environmental changes, regions, technologies. What we try to do is incentivize our technicians to look for better ways, look for optimal training courses. It's great to have all the high-end tools and high-quality tools. If we don't know how to use them, we're actually doing a disservice to our clients. So as part of our smart people, it includes the ability to understand and the feedback that is also coming back from the plant. So we talk about data, smart monitoring. You know, even a 1 megawatt plant has gigabytes of data coming back from it. So if we're pulling 1,200 points of data every 5 minutes for a 10-hour day, that's 144,000 data points that we get per day. That's great. What does it mean? It's not so much about gathering the data, it's about how you digest it in a manner that we can quickly and easily understand. Some of the monitoring systems, as Jeff touched on, look at, you know, events, issues, problems as one. You know, an event for us is just, it's informational. The issue is something that needs to be dealt with. A problem is something we have to deal with right now. The alarm is the notification, and the alert is you have something coming. If we have the capability to prioritize those, it makes us more efficient. So there's a bottom right picture. It's a scenario that happened to us not more than 3 months ago. It says grid voltage 70 kV nominal. We had this happen on one of our plants. The utility had informed us that the grid was 70 kV. So we go and we fired the plant. As you can see from the graph, we never hit 70 kV. We're actually 5% above the nominal voltage that they told us. Behind the graph is our log files comprised of all the inverters on the site, and what we tried to do was trend those and see what this high grid voltage effect had on the inverters. By being able to digest the data between the voltage and the effect on the inverters, we were able to determine that we needed to tap down the transformers on the skids in order to put the voltage swing between basically the sweet spot of the AC side of that inverter. So as we go back to our LCOE discussion, the equation that we pulled directly from the NREL site, the items, you'll see the first 2 items, those are the only 2 items that are not relative to O&M. Everything else has something to do with time, value, over time. On the right is how we've chosen to look at the issue. The priority is always asking the question, is something broken or not working, and is it losing energy, and is that losing revenue? Sometimes, depending on your PPA structure, losing energy and losing revenue are the same. Sometimes they're different. By always keeping an eye on loss of revenue, it'll help prioritize everything right out of the gate. Sometimes we can prioritize or schedule issues later, and sometimes we have to deal with them right away, but we always keep our eye on loss of revenue as our priority. So here we show some images of tasks that we all perform daily. The left are the visuals of, you know, an inverter, combiner box. The middle is our standard testing that we're done. And the last set, you know, we look at the photos, and what does it mean? What does it mean when you look at a hotspot on an image, on a thermal image? Our technicians, our technicians have to be trained in the equipment that they're using. In order for us to get high quality results, we use high quality equipment, and along with that needs to come a certain level of training. Here's another real life scenario that some of you may or may not be aware of. This is a ground fault that was caused actually by a ground squirrel on one of our projects. So it's a fault from a DC feeder, and it tripped out a 500 kW inverter. So we get calls, you know, we notice that you're going to get a call from the owner. Here's some of the questions that they're going to ask. So we have 2 different ways to look at it. You know, we'll call it a simple O&M versus the smart O&M. So whether you're the owner, developer, or asset manager, they're going to ask us the same questions. Our approach, and where we would love to see the industry go, is to more of a proactive approach towards the smart monitoring will recognize and report the alarm, give you the data required for the smart team to aggregate that data, form a plan by transmitting the data back, and finally to a smart resolution to locate, repair, and report the fault. I think the one thing that we all agree on that we never want to report back to our clients are, we don't know. And with that, that concludes our presentation. Thank you.
Thank you, Angelo. Appreciate it. Well, we have a couple of questions, and feel free to continue to submit your questions as we go forward. The first question that we have is, how do you establish a threshold for raising an alert?
We set deviation. Well, this, Angelo. So what we do within our system is we will pick deviations, and we'll set a percentage based on the modules and the string size. So we'll set a deviation, whether it's, on the back of a module on the nameplate, it'll say a plus or minus 6%. With voltages, we'll put a plus or minus 3 to 5%. Just depends on the system that we're using. And what that will do is it'll trigger a deviation alarm within that box for us. Then we'll know whether it's maybe a fusing issue or, unfortunately we haven't experienced anything like Jeff, which is great, where we haven't had seagulls drop clams, but to trigger something in that sense is how we do it.
Jeff, you want to jump in there?
Yeah, there are some default settings that the monitoring manufacturers that we work with use. We use Draper and Locus and a couple others, and they'll have default settings. Usually it's like if the performance falls below 5%, or obviously if it shuts off, and those are settable. And we've had a couple sites where we knew that there were some problems, but we didn't want it to keep sending alerts at the 5% level, so we would set it down a little bit lower than that. It really depends on the site. But in many cases, we start with, or in all cases, we'll start with the default setting.
Is there a rule of thumb as to how much O&M costs per kilowatt DC for a power PV plant?
Yeah, that's a great question, actually. I'll start with this. This is Jeff. In the analysis that I've done, it certainly depends on the size of the system, but I've seen numbers anywhere between 1% up to 10% of the value that you're getting. So that the value of the electricity that you're producing, and you're the investors are expecting to get in some form of check once a year or more times. 1 to 10% must be set aside for an O&M program. If it's a smaller system, then obviously trying to have some kind of a set package where you have an annual fee that might just for a truck roll, it costs a certain amount of money, and you may be closer to the 10% program, but allow for somewhere between 1 and 10%. And for projects that are much smaller, let's say 5 or 10 or 20 kilowatt systems, we have what we call our bronze package. It's really a time and materials package where we'll do the monitoring and alert notification and some basics, but then every time there's a truck roll, we'll just charge on a time and material basis. That way, it could potentially minimize, the cost to the customer.
Yeah, we take a different approach. We don't do a lot of the residential. Most of ours is utility and larger DG projects. We do it it's a kilowatt price per DC, and we see it ranging anywhere from $10 to $12 a kilowatt is kind of what we've seen in the industry.
I would say that we also, for larger systems, we're in that same range. But I thought it was useful to mention it from a percentage of revenue, so we can really look at it from two sides. If you're getting a quote, you put out an RFP for a O&M program, and you're getting numbers that are somewhere around $10 to $12 per kilowatt, then you know that at least you're pretty similar to Vigilant Energy Management and Swinerton.
Right.
So roughly what percentage of suspected system soiling loss would you normally recommend module washing?
Anything?
Start with this one, Angelo. You probably have more experience with dust out there in the West.
Yeah, that plant right there, believe it or not, was a 20% uptick when we washed it. That plant had never been washed from the first time it was built. So when we came in at commissioning is when we noticed that. But traditionally, we'll do it. We try to time washings. So let me answer your question. The first, anywhere from 2 to 5%. And then from that, what we do is we try to time the washings. Depending on how the PPA is structured, some owners get, TOD rates, and we really try to hit it hard and aggressive during the times that the owner is making the most revenue.
Do most of the programs base the frequency of O&M on time or performance?
Most of the contracts that we see are based on a 1 year, a 1X shot. We typically, that's not our approach when we do a plant. We hit plants every month, and we break the sites up into respective numbers, so we get a representation every month of how that plant performs as a whole. We've never felt that hitting a site once a year and being there for a couple of weeks doing your testing and leaving was the right approach over the long term. So we've broken that up into different parts and pieces.
I'll just chime in a little bit. With Vigilant, we do semi-annual and annual, and then on a case-by-case basis, we go out there more often. Certainly, if the site is a ground mount where we get a lot of tall grass, we're going to be out there much more frequently. And we're also in the process of setting up remote cameras so we can actually have video feed on a daily basis, so we can at least get a look at part of the site on a regular basis. So it's almost like being out there almost daily. I also want to say just a couple words about the soiling. Here in the East, where most of our systems are, we find that rain is frequent enough that regular annual washing isn't necessary, but there is a bit of a dirt dam that builds up on the lower edge that does need to be washed off, probably on a 3-year basis on average, sometimes a little bit more frequent, depending on the site. But we're pretty lucky getting a natural washing on a regular basis out here.
In regards to cleaning or washing the panels, is that something that you would have technicians that do that, or would this be a service that you would outsource?
Currently, we are outsourcing. We've done washing in-house, but what we find is that our electricians are, time lost for their level of knowledge and experience is better used, to be analysts and technicians, and we sub out washing for the most part. We found a couple contractors that have very strict standards, and they do a really good job. So they have the equipment, they're set up for it, and it's actually better bang for the buck in our case.
And we do both. It depends on the site and the timing of the site. Our techs prefer to do it themselves, to be honest with you, because they get greater visibility on every single module. But on the event that we do outsource it, that's part of our contract requirements that that we tie them to. We want to know if there's a fractured module in the field or something that doesn't look right.
How do you determine what subcontractors to use for various activities, like as we were just talking about module washing? What are the criteria you use to evaluate them?
We interview,
on our case.
Yeah, we interview them, and it's critical. Like before anybody gets on our site, that they have to understand PV and PV behavior. And some of the partners that we use, they do understand that.
Yeah, we don't want to contract to a window washer that wants to get into PV modules. I mean,
no, absolutely not.
How do you determine the value of O&M? What is your criteria for determining the value of it?
like as in terms of costing, or what the value that we provide a customer?
Or the value that you provide a customer.
Oh, okay. So on the larger plants, you're typically tied to the performance guarantee, which is determined by some mathematical equation of, with the PV cyst and degradation and your expected output. So we're tied to a specific number. Our goal is to always supersede that number. So the value that we feel that we provide is we're superseding the numbers that we're mandated to hit or contractually obligated to hit. Because all of our technicians are in-house and they're specialists in all different aspects of the plant, we can respond sooner, which was something that we learned also the hard way, where you have to rely on somebody else. For your success, we chose to bring that in-house and hire our own specialists so we could respond.
Yeah, just to add to that, I would say for larger systems, that cost analysis that I did, where I determined that it was about $6,000 per week loss, that's a good way to quantify the value of O&M or the cost of not having O&M. With much smaller systems, it may be tougher. If you have a lot of residential or small commercial systems, even up to 50 and 100 kilowatts, it's a little tougher to do that kind of cost analysis, and you're going to be higher on the percent value per year scale. You may be spending 10% of your winnings per year on an O&M package if you want something that's kind of a prepaid package that is pretty comprehensive. And that's why for smaller customers we go with something that's more on a time and materials basis, and that way it's still unknown, but that's sort of the nature of kind of like the weather. You just can't predict it. But overall, O&M is critical when you consider that these systems are supposed to operate for 20, 30, 40 years. There's no way that anything can operate for 30 years without O&M. Your car certainly doesn't operate for more than 3 months without regular maintenance. So there's no reason to think that very complex power processing systems would.
So how do you handle monitoring the power levels? For example, 5% drop needs investigation when shading by clouds is present. Specifically, if the PV field is large enough to have shade in one area but not register shading on the station instruments.
But we post on some of these plants that we have that are 100 or 200 acres, we have several weather stations peppered throughout the field. So when we notice a drop in production, one of the first things we're going to check is to see what the irradiance levels are in that specific zone, just to make sure that we're on the same page.
Yeah, and similarly, when we use a number of inverters, we'll have monitoring for each of those inverters. If a site has 5 or 10 inverters, we're going to have 5 or 10 data sets. And if they're shadowing on one of those, on the array for one of those inverters, it's going to show up on that data set totally independent of the others. There's also string level monitoring that we've done on a number of sites. So that really takes the granularity down to not quite the microinverter level, but it's sort of a compromise between microinverter level and larger central inverter.
We've been talking a little bit about the communication between the monitoring systems and the central area where they have people monitoring them. And somebody asked, what's your opinion on the SunSpec Alliance, which is trying to standardize the industry information standards to enable plug-and-play systems interoperability?
Angelo, you want to take a crack at that one?
I'm not real familiar with that.
I am not as well. That's why I deferred.
Gotcha.
I like the idea, theoretically, of having some kind of a standard, but I don't know enough about it to really voice an expert opinion.
Right. And we're of the same opinion. There's certain things that we want to see that may not necessarily be something that somebody else wants to see, but in terms of operations, we see it as being useful.
I gotcha. Somebody asked for some clarification on the 10 to 12 per kilowatt. Is that per day or per month?
Per year.
Per year.
Yes, correct. That's on an annual fee basis. And of course, what that means is determined in the actual statement of work. So you would have to read through a contract to find out what you're actually getting for that 10 to 12 dollars per kilowatt. And based on the price, it sounds like our two companies are offering pretty similar services because we're coming out to a pretty similar price.
Right. Angela, I've got a question for you. When you do wash panels, do you run an RFP or do you just sub to local washing companies?
No, we've established relationships with certain subcontractors within a geographical area, and that's who we use. We always try to use somebody regional.
Do the meteorological stations require regular maintenance and cleaning as well?
Yes. Sensors should be cleaned at a minimum. We feel your pyronometers, GHI sensors should be cleaned at least once a month. We're making sure that there's no cobwebs in those weather heads and everything's functioning properly. And every 6 months, what we'll do is we have a test meter kit that we'll put adjacent to it just to make sure we're reading the same irradiance values that's populated on the monitoring system.
It's also important to make sure that the temperature sensor is adhered to the back of the module and doesn't come loose. We've seen that on one or two sites.
So somebody asked, even if you do perfect O&M, if the weather is wrong, the system will never reach its desired performance. How do you deal with something like that?
Well, these systems are, we use PV6, which is like PV watts, but much more sophisticated. I think it's sort of the standard these days. And so when we do an analysis, we're looking at historic data over, let's say, maybe the last 10 years. Of course, what is actually going to happen next year or next month is whatever happens. So many times what we find is that the actual recorded and measured performance is going to differ from what was modeled. That's what you should expect. It's the difference between climate and weather. Weather is what you get. So what we found is that over time, it follows it pretty closely. Because it's averaged over 10 years, so the next 10 years is probably going to look pretty similar to the last 10 years in irradiance. I don't know about temperature of the Earth, but so over time you'll find it gets more and more accurate. But on any daily or monthly basis, you could be off by 10% of what was modeled.
Agreed. Yes.
Do you recommend the plant owner purchase an extended inverter warranty?
Yes. That was easy.
It depends. How's that?
Yeah, I don't know. Time. You forget that one.
Yeah. I think for us it depends on, where we are. And if you're trained in that, being factory authorized, there's a lot of stuff that we could do for a client that they don't necessarily have to be involved in, or for asset managers that, we could take care of certain issues with specific inverters.
Somebody asked, what is IV curve tracing and how do you do it?
Yeah, great question. IV stands for current and voltage. The I is current intensity. And so what we're looking at is a tracing of the current and voltage going from 0 to infinity on both of those values. And it traces out a curve, and we look at the shape of the curve to determine if there are anomalies. this is one of the methods, just as critical as using infrared imagery. You're going to see things that just taking a voltage check with a multimeter isn't going to tell you, or any kind of a visual inspection. So that reading those curves takes some skill and experience, but it is another very important tool in the analytics process.
Correct. We typically, there's typical requirements that you do 10% of operating current, open circuit voltage, and then they have this requirement for IV curve tracing. We typically tell the owner that they don't necessarily need operating current and open circuit voltage because we'll curve trace those modules. And, like Jeff said, it gives you better accuracy, and it actually compares it to the STC values of the module manufacturer.
And that's actually similar to what the module manufacturers do when they flash test each module. So it's staying consistent with that same test method, except for now we're doing it on the string level.
Somebody was asking about if you need a quick response, spare parts are critical. So who's responsible for ordering and maintaining that inventory?
For us,
go ahead.
We put together on a project that we EPC, we put a package together for the owner to purchase the spare parts. If we're doing third party, we'll typically include the spare parts. If it's inverter manufacturers or tracker folks that we're certified with, we carry the spare parts. We're allowed to be a spare parts hub for them, so the owner doesn't see the expense of spare parts, and we track them through our monitoring system, through our inventory control.
Yeah, for us, pretty similar. Every project we're going to set aside a certain number of modules as spares, either right on site or in a warehouse, just for breakage and anomalies. And in the case with SATCON inverters, since that company went bankrupt, we invested in a quite sizable inventory of parts because we don't know what the future availability of those parts is going to be. So it really depends on the project and the site, but there's a certain amount that we will automatically inventory, and with companies that we think are pretty healthy, and all the press and media sounds good about them, we will keep less inventory of those.
If there's somebody who asks if they want to do O&M in-house, what kind of training do you recommend?
Experience doing it. I mean, there's so many things that can come up. So I am the director of O&M at Vigilant Energy Management, but as a side consulting before I started with Vigilant, I was a trainer. I did that for a number of years, 5 years, and one of the trainings that I've done is troubleshooting and O&M. And so there's a certain amount of classroom teaching that you can give. If you go to folks like Solar Energy International and others, they can provide a certain amount of good classroom experience, or at least learning from the experience of others. But it really is just doing. Get all the test equipment and just keep doing it.
I agree. And then I'd add, with the techs, you almost have to look for specific technicians that are real passionate about the industry and passionate about what they do. I think if we find out there that, these are guys that just want to punch a clock, it doesn't necessarily work as effectively as it should. I mean, our business is essentially sun up to sundown, and, it's not cut out for everybody. So trying to find that right fit is hard, and I think that's the key.
What differentiates your services from all the module manufacturers who have their own O&M services?
Well, I don't think I could answer that completely because I just don't know enough about their services. I think that based on what I've investigated of the industry, Vigilant offers the highest level, which certainly meets all of what we've seen and exceed in many cases, but I don't know enough about module manufacturers specifically. I think they keep a lot of their expertise pretty close to their vest.
Yeah, and we've seen that too, where certain module manufacturers will do a specific portion of O&M. Inverter guys want to do their portion of O&M. For us, we could get there faster, and at the end of the day, we're also less expensive.
Yeah, us as well.
Well, we've hit the 3 o'clock mark, but we've got a few more really good questions that I'd like to get to. So we're gonna go a few minutes over. What's
Sure.
the difference between O&M and asset management, and is there a difference?
Yes, there is a difference. Our company has 4 different levels of services. The highest level of service, which we call our Platinum program, is true asset management. So it's not just an O&M program to maintain the productivity of a plant, but it also includes billing and metering and all of the other services that an owner would have. So, in a regular PPA agreement, you have the owner, you have the host, and then you have the EPC who installed it, and maybe that's the O&M company as well. But to do the metering and billing of the customer and to have that business relationship with the host customer, that's really where the full asset management comes in.
I would agree. It's looking for a service that can do everything. And out here where we're based out of California, we have a lot of reporting requirements to the grid management company, which out here is CalISO, and in Texas there's another entity. Being able to work that interface and manage the entire plant.
What is the most efficient way to remove soiling effectively by way of in-house to subcontract?
Water.
House.
Let it soak in. If you can get it in the morning when the panels may be moist from dew, or after a rain when they have had a chance to soak, that's your best time when the soiling is going to be the softest, the mushiest, and then you can brush it off with a soft brush.
Yeah, agreed. And also looking at the type of soiling that you have, if it's like a fine, almost like a sandish soil, you may be able to just spray those instead of doing a full brush wash, do a rain simulation out there.
Yeah, exactly. We have one site that's next to it's for Purdue actually, and they're right next to a big agricultural center where they're running big combines in the field, and all this dust from the field comes over. Just to pass by with a hose is all that needed. In many cases, we might have a dry summer where it didn't rain for a couple months, and just to pass by with the hose is all it needed.
If you use a simple pressure washing technique for washing modules, does the high pressure water damage the panels over time?
It's not recommended to use high pressure. Low pressure, below like 600 pounds, is what the module manufacturers recommend.
Exactly. Yeah. In every module manufacturer cut sheet, there's typically a PSI requirement that you need to stay below.
Is back to the IV curve tracing, is that done through the monitoring system?
No, not yet. I don't know of any.
No. It's special meters that are, I think Seaward makes them, Trica, Oxaflux has some.
Solmetric makes one.
Yes.
So yeah, these are separate devices, field handheld devices that you're gonna be taking a irradiance meter measurement and then looking at each string individually to get a tracing of them. So it's separate from the monitoring. Maybe one day in the future we'll have it built in. Hint for those entrepreneurs that want to invent something new. We'd love to have that solution if it's a good price.
Yeah.
The question is deionized water really necessary for cleaning?
No, not
No.
necessarily. It depends on the water quality of where that you already have. If you have heavy water, then you're going to be leaving deposits. But if you already have a good source that's soft water, then no, that would be an expensive way to do it and unnecessary.
No. And we've challenged owners when they've asked us that, in the same sense, to ask them that, you know, these plants get rain. I mean, the rain isn't deionized. They're fine.
All right, we have two more questions. How important is the IR camera as far as quality? They have a FLIR i7, but from some articles that this person has read, a camera with high pixels is important. Is this true, or will any camera do?
No,
well,
I
we
think,
use pretty high resolution cameras.
Yeah.
Generally, you know, anything less than $6,000 is just not going to do it. You know, the FLIRs that we use. Obviously, you have to fit it in a budget. And a low resolution camera is going to be useful up close. You know, you're going to catch those wires that are overheating and stuff like that from a close range. But if you want to, you know, use a drone copter at 100 feet and look at a whole array, you're not going to be able to see cell heating. So you know, if you can afford it, it's a good investment, and you're going to be able to distance and see more at one shot.
I would agree. We use the FLIR cameras throughout our entire portfolio. I think when you look at all the and we did studies on the cameras out there, and ultimately, at the end of the day, you're going to get what you pay for, and you want that visibility, like Jeff said, in order to make a proper diagnosis.
All right, and the last question is, with all the different panel manufacturers out there, what's the most effective way to prevent delamination?
I would say use a high-quality manufacturer. Some of the top-tier manufacturers that we've used with module installs, we have not had an issue to date on delamination.
Yeah, that's just second what Angela said. We haven't seen a lot of delamination, so I really can't speak to that.
Well, I'd like to take this opportunity to thank Jeff and Angelo again for all of their insights. This is obviously an issue that is only going to increase in importance the more solar that gets installed, and we really appreciate you taking your time out of your day to share your insights into operations and maintenance with us. If you didn't get a chance to ask, if you didn't get a chance to ask your questions of Jeff and Angelo, you can certainly send your questions to me at fandorka@solarpowerworldonline.com, and I will pass them along. Thank you, everyone, for attending this webinar from Solar Power World and EDF Renewables. Please look for this presentation in your inbox. We will send that out in the next couple of days, and it's also eventually going to be available on solarpowerworldonline.com.
Thank you.
Thank you.